Welcome to Homework Lib.
Question: classify each red highlighted carbon atom as nucleophilic, electrophilic, or neither. To classify the red highlighted carbon atoms as nucleophilic, electrophilic, or neither, analyze their electronic environment. A nucleophilic carbon typically has a partial negative charge or lone pair, allowing it to donate electrons. An electrophilic carbon, in contrast, has a partial positive charge due to electron withdrawal by adjacent electronegative atoms or groups, making it electron deficient. If the carbon lacks significant electron-rich or deficient characteristics, it is neither. Structural context determines the classification accurately. Section 1. Classification of each carbon atom. A. Methyl carbon. This is a simple methyl group, CH3, with no functional groups attached that could alter its reactivity. Methyl carbons are generally unreactive in the absence of other attached groups because they do not have electron-donating or electron-withdrawing substituents. Classification: neither nucleophilic nor electrophilic. Section 2B. Carbon attached to bromine. This carbon is attached to a bromine atom, which is electronegative. Bromine is electron-withdrawing due to its high electronegativity, which pulls electron density away from the carbon, making the carbon slightly positive. A carbon with a slight positive charge tends to be attractive to nucleophiles, which are electron-rich species, meaning it behaves as an electrophile. Classification: electrophilic. Section 3. C. Carbon in epoxide ring. This carbon is part of an epoxide, a three-membered ring with an oxygen atom. Epoxides are highly strained rings, and the carbon-oxygen bonds are polarized, with oxygen pulling electron density toward itself due to its electronegativity. This polarization makes the carbons in the epoxide ring slightly positive, which attracts nucleophiles. Classification: electrophilic. Section 4D. Carbon attached to lithium. This carbon is attached to lithium, an alkali metal known to donate electron density to carbon. In organic chemistry, a carbon-lithium bond is polarized such that carbon has a partial negative charge because lithium is less electronegative than carbon. A carbon with a partial negative charge tends to donate electrons, making it nucleophilic. Classification: nucleophilic. Section 5E. Carbonyl carbon in ketone. This carbon is part of a carbonyl group, C=O, in a ketone structure. In carbonyl groups, the double bond between carbon and oxygen is polarized because oxygen is much more electronegative, pulling electron density away from carbon. This results in a partial positive charge on the carbonyl carbon, which makes it electrophilic as it can attract nucleophiles. Classification: electrophilic. Section 6. A. Neither nucleophilic nor electrophilic. B. Electrophilic. C. Electrophilic. D. Nucleophilic. E. Electrophilic explanation. His question is from organic chemistry. Specifically, it focuses on reactivity and functional group behavior in organic molecules.